if you think that LLMOps, MLOps and this DevOps are all related to the cloud, you're actually right. You're not wrong. But if you think that this is the way you can get to the cloud, then you need to watch this video. So here, this is Akshay Nadan and welcome back to a new video. And my focus in this video will be to tell you the difference between this LLMOps, MLOps, DevOps. We will see the basics, we will see the flow, we will see the cycle, how these three work differently. They are all quite separate from each other, not 100%, but they have some additions and some subtractions. So you need to watch this video because nowadays LLMOps questions are also getting asked to DevOps engineers, to SD engineers who are going to work on the cloud. MLOps is not new, it is quite a old domain. But nowadays, focus is also on the LLMOps because almost all of the companies are adopting LLMs, multi-agents, and these orchestration tools in their workflows for some of the other features, right? And DevOps, we all know that what is the purpose of DevOps. But if you don't know, I'm going to cover it. No worries. So whenever we take name of these three words, LLM plus ops or ML plus ops or DevOps plus ops, something needs to be automated. Okay. So you need to just keep one thing in mind that whenever these any of these term come into picture, something is getting automated. What is that thing, right? Some process is getting automated. The process is different for these three, some way or the other way. But let's figure out. Okay, so let's go one by one. But before that, I'm happy to tell you that I have created a new Discord server for solving all of your queries and doubts. So this is a new server, people are still joining. So I'll be happy to solve your doubt and do join it. Various channels are over here, resources, news, questions, showcase and opportunities, hiring. Some of the founders are also joining. So do join it. The link is in the description. So let's pick the first one, that is DevOps. So you know that this DevOps is made of two words, developer plus operations. So this means that some of the processes that are actually taken care by the developers, plus some of the operations and some of the tasks that are actually taken by the operators or the people who actually deploy stuff or maintain stuff. This is the combination of those two tasks, right? So developer operations basically focuses on the CI/CD. What is CI/CD? Continuous integration and continuous deployment. I'll teach you this in a bit, but for now you can keep this in mind that the tasks that are getting automated in this DevOps field are focusing on CI/CD, that is continuous integration and continuous deployment. Monitoring of what? Monitoring of your app, monitoring of your server, monitoring the logs, monitoring the analytics, monitoring the cost, monitoring the budget, right? And in LLMOps, it will be monitoring the tokens that are getting consumed or whatever the cost is coming, right? Or the context length and everything. So monitoring and scalability, whether the system that you have built, because when we use DevOps, right? When you have built a system, right? And whenever you make a system, you need to make sure that the system is scalable and maintainable, right? So scalability is one of the other factor that is taken care in DevOps, that whatever system you make, let's say you build an e-commerce server, or let's say you make a image background remover server. So if millions of users hit your server, it should be scalable, right? So that is also taken care by DevOps, so that if there are spikes in your usage, then your DevOps setup, your pipeline should be able to handle that using auto scaling and all that. So this is all a part of DevOps, and the focus is to improve the software delivery. Okay, now let's see the DevOps cycle, and don't get overwhelmed by seeing all of these tools. As a DevOps engineer, you're not expected to learn or know all of these tools at once. As the requirement will come, then you will be learning and working with them, right? And some of the tools you will already be working with, right? Like Git, NPM, right? Office, Drive, Draw.io for drawing architectural diagrams, Asana, or AWS, right? So all of these tools, you don't have to learn all at once, right? GitHub, Docker, right? So these are all the tools, but the main thing that we need to focus on is in this cycle, right? So whether it is MLOps, whether it is DevOps or ML or LLMOps, it contains a cycle, right? And you will be, as a DevOps engineer, your task will be to set up this cycle or maintain this cycle. That's it. That's the task of a ops person, whether it is MLOps or DevOps or LLMOps, right? So first of all, just think of making an application. Just think of making a project, right? So what you do, what is the first step that you need to do when you create an application or start building an application? So first step is definitely planning, right? So planning is your first task that you need to do. So for planning, these are some of the tools that you can use for planning, like Lucid Chart. This is a tool where you can draw engineering diagrams and charts, right? So that is very useful for drawing system design architectures. Then Draw.io is another free tool, right? Then you can use all of these tools. You can save all of these tools in Drive, or you can use this Office for presentation. You have to make a plan, and you also need to present to your engineering manager, right, or in front of the developers. So this all comes as a part of planning the project. Okay. The next thing is building. Once you have planned it, then you need to build it. So building is the second part, and these will be some of the tools that you will be using for building your server or building your project. Like GitHub you will be using for version control, npm you will be using for downloading the npm packages, node packages, Docker for containerizing the containerizing the application, right? Then Node.js you will be using, Kubernetes you will be using as an orchestration tool. So this build is the second step. Then is your continuous integration. This means this is your third step, and this means that whenever your app is ready for the version 1 or version 2, you push it to a version control system like GitHub, and it's not like that the push that you have made, it's the first and the last push, right? Client will tell you the changes, and you have to keep on making those changes. Bugs will come, and you have to keep on solving those bugs, right? So you will be continuously pushing those changes to the version control. So continuous integration means that you will be continuously, as the new changes will come to the main branch, you will be continuously integrating those changes in your pipeline, in your deployment pipeline, so that they automatically get tested, those features, and they automatically get deployed on the internet, so that users can start consuming those after testing, right? So that is the power of, or that is the use of continuous integration, so that your changes continuously get integrated to your main pipeline. Okay. Then the deploy. So this is the fourth step, deployment. So once you have built your application and you are ready for, you have also integrated, now you need to deploy it. You have to deploy the application on cloud, right? Because there are very less companies now who are using on-premises servers. Some hospitals are using, and some high security data companies are using on-premises, but most of the consumer applications are using cloud. So that means you need to deploy your application on cloud, or in simple word, it means the internet, right? So AWS you can use, Amazon Cloud Services, right? Amazon Web Services, Azure by Microsoft you can use, GCP you can use by Google Cloud Platform, right? Heroku you can use, Vercel you can use, Chef you can use, Puppet you can use for all of the deployment stuff. Okay. So this is the fourth step in the cycle, and don't think that I'm teaching DevOps, right? This is important for even knowing MLOps and LLMOps, because even for those two things, this DevOps is very important, right? So focus on this. So that was the deployment. The next thing is operate. You need to operate the application. Operation means monitoring, analysis, logs, because whenever you have built the application and your users are using it, they will face some challenges, they will face some issues. You need to figure out which part of the user is not getting consumed by the user, which part of the user or which area of the website or your server is getting mostly used, or which service is getting mostly used. So if that service is getting mostly used, then you need to upscale that, right? Using vertical scaling or horizontal scaling, you can upscale that. So you need to monitor that. So you need to operate that, right? So monitoring tools, analytics tools, logging are all a part of operations, right? So for that, these are certain tools that you can use. Okay. And last is your continuous feedback. So continuous feedback can be from any of the stakeholder. Starting from a user, it can be a user feedback, it can be manager feedback, it can be any of the stakeholder feedback. Even the founder can give you feedback, even a normal developer can give you feedback, even an intern can give you feedback. Feedback can come from anywhere. As per the feedback, the cycle will again get in the flow, right? Again, you will be planning to how to fix that or how to work on that feedback, and then you will be again following that process. So this is DevOps. One of the example, if I just give you, if you are new to DevOps, if you are not new, you can skip this. Company developing a banking web application uses DevOps pipelines to automate code testing and deployment, correct? As we saw, monitor server health and application performance, perfect. Enable rapid and reliable updates. Tech stack that they are using, a banking web application, they are using Docker, containerization, Kubernetes for orchestration, Jenkins, GitHub Actions, and Terraform. So these are certain tools that you will be using as a DevOps engineer. Okay. Real world case. Netflix uses DevOps to ensure seamless streaming by automating deployments and monitoring traffic. You know, Netflix has like billions of users, right? So and people come there to stream videos. So it's not an easy task. It is actually rocket science. Okay, so you need to set up perfect and seamless DevOps cycles so that users don't face any challenges even if the traffic is huge. Now let's see the MLOps. So MLOps, as the word defines, machine learning plus developer operations. It is not machine learning plus operations. It is actually machine learning plus developer operations. So whatever you learned in the DevOps will be used in MLOps also. Okay. So this is a process that involves creating, deploying and maintaining machine learning models, right? So there we were actually maintaining, deploying, creating the web applications, right? Servers or web apps and all that. But over here, we are actually doing all of that stuff for models. Okay. So an MLOps engineer will be working on doing all of this stuff on models, and DevOps, a general DevOps engineer will be working on all of this stuff on web applications and servers. So MLOps is a collaborative function that often includes data scientists, DevOps engineers, and IT. Data scientists and machine learning engineers also. Okay. So on a high level, this is the definition of an MLOps engineer or the MLOps. Now let's go deep. Okay. So as I know, as I told, MLOps is ML plus Dev plus Ops. So in ML, what you will be doing? You will be doing data management. So that means, so let's take an example of a company. Let's take Walmart, right? So there you need to continuously import the data. Data of what? Data of the users who are buying, customers, data of your warehouse, like these products are available, these products are not available, or customer feedback, that this product has the best feedback, so it might have huge demand, so we should always keep it in inventory, right? So this is all the data, right? And whatever results I just gave you, that hey, this product has the best feedback, so we should keep it in inventory. This was the task of the data scientist to come up with the predictions. So I actually gave you the predictions, seeing the data, right? So what I did, I saw the data, and based on that I did some predictions, and based on those predictions I took some decisions. Okay, so that is the task of ML plus data scientist, that you import the data from the data warehouses. So data warehouses are actually the places where all the data is present. It's not a physical entity, it's actually a software entity itself, like SQL, simple terms, PostgreSQL. Big data will be present in some big data warehouses, right? So GCP, AWS have all those tools. Azure has all those tools for storing the big data. And from their big data warehouses, you have to import that data as a machine learning engineer or as an MLOps engineer also. Okay. So experiment with that data, acquire that data for some predictions, understand the data from business point of view, and model that data. Initial modeling, right? So initial modeling, this is not data machine learning model making, but this is initial modeling. Initial modeling means you need to model that data in some form, right? Data might be present in some unstructured format also. So you need to structurize it and model it in a consumable format for data scientists, right? So data management and model development. So model development means you will be making some machine learning models for predictions, right? Then model deployment. So you need to deploy that model, right? So that users can use it or the clients can use it. So where will you deploy that? So that all decisions are taken care by MLOps engineers. So deployment are also usually done on some machine learning cloud tools, which are provided by some cloud services like AWS. Like you can deploy on Bedrock, using Bedrock or some other cloud tools. But this is the next step. Then again, monitoring and logging, right? So you also need to see what are the predictions that are created by this machine learning model. Are they correct or not, right? So you need to see your classification reports, you need to see your results, and based on that, you will keep on improving your cycle, right? So whatever logs that you're getting, whatever feedback that you're getting, you need to keep on improving your model so that your cycle is always getting improved day by day. Then model governance is again monitoring and compliance. So your system should also be compliant with some of the regulations, right? Like HIPAA compliance is there or some other compliances are there. So this always doesn't it mean the government compliances, but other compliances can also be there. So your system should always be compliant with all the regulations that are there for your system, for your industry. Okay. So this is the basic MLOps cycle. Basically, we are doing DevOps itself, but some other pre-steps are added to this cycle, right? You need to work with the data and then that thing will again be attached to your DevOps cycle. So let's see this example also. Healthcare startup builds a medical image diagnosis model using AI. So that means medical image diagnosis model. That means this model is there, which is going to predict something. Seeing a medical image, let's say cancer image or brain tumor image, this model will be able to predict something using AI. So MLOps helps automate data pre-processing and model training, because in this data set, there will be many images that are not useful for us, right? With some noise or some other thing, you have to remove those. So that comes under the process of data pre-processing. Okay. Then deploy the models in a scalable production environment. You need to deploy it, right? Continuously monitor model performance, detecting the model drift. Tech stack you will be using MLflow, right? Kubeflow, TensorFlow extended, TFX, Apache, Airflow. So these are some of the tools, very famous tools these are, which are used for MLOps cycles. Real world case, Uber uses MLOps for its dynamic pricing model, optimizing fares in real time based on the demand and supply. So you have also experienced this, that if there is no driver in your area, the rates will increase. So that because the driver has to come from far away, right? Recently there is a news that some people are seeing more charges on iPhones, and for the same time, for the same driver, people are seeing lesser charges on Android phones. So from where does this thing are getting created? Like these models which are able to detect or predict what price should we give to the user based on all the parameters, right? So this is all a part of MLOps, and companies like Uber and Ola are using this to exploit us. Okay, but yeah, great technological advancement. Okay, so this is again MLOps. Now we can move to LLMOps, which is the latest trend. Many MLOps engineers are also upskilling themselves to learn the LLMOps also. Okay, so as the name defines, it is LLM plus developer operations. Developer operations is not going anywhere. DevOps is there. So LLMOps or large language model operations is a set of practices and tools for managing and operating large language models. So previously in MLOps, we were handling or managing the models, machine learning models. But now we need to handle large language models. These are quite advanced from the normal models in terms of size, predictions, context lengths, or the impact, right? They have much bigger impact, right, on the industry. So LLMs are AI models that can perform natural language processing tasks. That's it in simple terms. And now we need to manage these LLMOps, because in a company, in a very big company, you will not be working with one LLM. There will be multiple LLMs, multiple agents working together, talking to each other in your system, right? And you need to orchestrate these LLMs and your agents. So this is all a part of LLMOps. Okay, so let's see. Thanks to deeplearning.ai and Google Cloud for this picture. So what is there in this LLMOps cycle? So first of all, again, data preparation and versioning. So data preparation and versioning will be your step number one. We need to prepare your data and you need to version it. So once you have version it, you will be providing that data, version data, to a pipeline. So supervised tuning, whenever you hear this word supervise, right, whether it is supervised learning or supervising, right, something. So that means that the environment is supervised. Supervised means there is someone or some entity that is supervising the whole thing, right? So supervising means there will be, in very simple terms in machine learning, what happens, there will be training data, there is testing data, and you will have some independent features and you will have some dependent features, right? So X and Y, right? That means if you put this comes out. If you put this comes out, right? So this is where supervision comes into picture, because we now have some supervisor, right? You have some training, you have some testing data, but you also have independent dependent features which are telling you that, hey, if you put this into the black box, this is coming out. So that is actually acting as a supervisor. So just this data, prepared data and version data, you need to put into your pipeline, which is actually called supervised tuning. Okay, and the thing that comes out is an artifact. Artifact has a version, artifact has a configuration, and artifact is responsible for a workflow. That means artifact is responsible for some task, and this is mainly containing your data, right? Data is there inside it. You can understand like this. Okay, after that you do all the automation stuff. As I told, all this LLMOps and all that, they are automating something. So what are they automating? They are automating this pipeline execution, and they are automating this deployment of the LLM. Okay, So you need to execute your pipeline. So whatever pipeline you have designed for your LLM, you need to execute that pipeline and you need to deploy that LLM. Okay. And after that only you will be able to send prompts to your LLM and get your responses. And when you have got the predictions, you cannot send directly those predictions to your client. You need to make sure that your AI is responsible. That means you're not sending some random junk to the user. Otherwise it will be useless for the user, and their tokens will be used and their cost will also be used, right? So you need to make sure that whatever regulations, whatever compliances, or whatever like whatever you are doing, you are sending the responsible response to the end user, right? Let's say you are building such system where there is no way you can generate some harmful responses for users below 18 years of age. So you need to block that. So all of that work is actually done over here. Okay. So preparing the data, design your pipeline, generate an artifact. Once the artifact is generated, execute the pipeline, deploy the LLM, and generate the prompts, generate the predictions. And then have a check on your predictions and then send it to the user. Very simple diagram this is. Now final thing is this diagram. I think it might get overwhelmed for some viewers, but just watch it. Okay, just go with the flow and just watch it. So over here, thanks to Insight Partners for this image, but let's go one by one. So this diagram looks complex, but this is very simple diagram. Let me do one thing and you will find it very simple. So see these blocks. So this is block number 1, right? So this is a block, and this block is for pre-training LLM to downstream the task. So pre-training. So as I told, as we saw in the first diagram, you need to pre-train your data. You need to get your data ready. You need to train your LLM. You need to get your LLM ready. So this is that box. And we have one box I can see for end user management. This is the box for end user management, right? End user will be just putting the prompt. So prompt engineering is a part of that. And they will be worried about their context limit and all the context. So context management is their end user task, end user management task. Then I can see one box over here for model deployment, right? You have prepared your data, you have trained your model on that data, but now you need to deploy that model. So this is that box. Then enterprise considerations. Enterprises. Who are enterprises? The big companies, right? They are worried about the performance of their model, so they need to keep monitoring their model. Then they are worried about the governance of their model, like who is governing that model, right? So that it can automatically take some decisions and it can improve itself. So that comes in the governance of the model. And there is security of the model, right? So that it is safe and secure for the end user, and it is safe and secure for that country also, right? So model security. Okay. Then I can see one box over here for model architecture and optimization. Okay. So for model architecture and optimization, we use tools like LangChain. Okay. So we use tools like DSci. So these are all the stuff. These are some of the tools. You don't have to worry about the tools right now. You just need to worry about the processes for now. Just focus on the processes. Okay. So model architecture and optimization is again a step in LLMOps. And finally, I can see a box over here for compute optimization, because this is not cheaper task to do. This is actually a costlier task. Electricity is used, GPUs are used, right? So whatever you're doing, you need to make sure that it is compute optimized and cost optimized also. Okay. So for that, you do some routing flows of user prompt. That means routing means whatever prompts that are coming, based on the prompt, based on the requirements, you route it to the correct parameters. If I'm understanding correct, parameters activation over here, routing means, right? So whenever your prompt is there, it will never be required that you have to activate all of the parameters of your model, of your large language model. Let's say there is a model with 6 billion parameters, right? So based on the prompt, let's say you are just asking the model to generate a Python code. Why do you need to activate all the parameters of your large language model? You only need to activate a few parameters. So based on that, you route it. Okay. Or some other meaning of this routing can be that you are routing it to correct LLM. If this LLM is best suited for solving mathematical problems, you route it to that LLM, right? If this model is creative, you route it to that LLM. Okay. So multiple meanings can be there. So runtime accelerator, right? So whether you're using RunPod or you're using Google Colab, so you need to switch your runtimes and you need to use the correct accelerator based on your requirements. Which type of GPU do you need, right? So for compute optimization, this is a task in that. For image generation task, you might need a higher power GPU. For text task, you might not need the higher power GPU. So OctaML is one of the tools. Then this is GPU optimization. RunPod, as I told, is the best tool. I also have been using it. But yeah, this is a overall idea about LLMOps, some of the processes in the LLMOps, and some of the tools in the LLMOps, and a basic pipeline. So I hope you like this video. I covered this thing on a high level, but if you want me to go deeper into one of the segment of this, let me know. I'll be happy to do it. And don't forget to check out the Discord channel, Discord server. So till the next video, keep coding, keep innovating, and thanks a lot.